So thanks for taking the time to come with us today. We're going to talk a little bit about where we're heading in the microservices world here. So my name is Jauch, and I'm a product manager here at HashiCorp, coming to you from California. And Erik is with us as well from Europe. And Erik will be jumping into the session in just a few minutes. Let me just change this around. So what we thought we'd do is just real quickly talk about what Consul is. Hopefully you've heard of it, and it'd be even better if you've used it. That'd be fantastic. But just for those of you that are kind of new to this, we'll just give you a very, very brief discussion about what it is, and then we'll get into some details of how it works. And Erik's got a pretty good example of how you can actually use it. So one thing that's really critical to thinking about Consul is to think about how compute and computing has moved in the cloud era. So if you think about this migration from physical servers to virtual machines and then containers, really what it is it's the movement of sometimes referred to as pets to cattle, right? So we had a small number of objects. I'm old enough to remember when the servers all had very specific names. The first server I ever managed was named Venus, and we had all our servers were named after planets because we only had 6 of them. If you have 45,000 containers, that naming scheme probably doesn't work for you. And so the complexity that is brought to the table has caused us to embrace things like automation, like automate builds and things like Terraform, and all these other pieces are really helping us do that. And Consul is just another piece of that same puzzle, and it helps us move forward in similar ways. Oops, wrong key, there we go. So if you think about what was happening before, if you had a very small number of relatively static machines, then your networking boundaries and the way that you talk to objects was relatively static. You would deploy a subnet, you would put objects into that subnet. Sometimes you could even have the luxury of having a subnet be a single purpose. So you'd have a subnet for application A, database is there, the data tier is there, everything's there, and you're done, right? Maybe you put some ACLs on your right, or maybe you don't. But as things get more complicated and more dynamic, which is what we want the dynamic nature and the ability to scale, that model kind of falls down now. Now you're talking about having service A talking to service B. Service A may be comprised of 10 containers, service B might be comprised of 100 containers. Maybe they're running on the same server, maybe they're not. Doesn't really matter. And so that flexibility brings huge power, but it brings complexity, right? And so the idea here is that instead of a traditional static approach to networking, Consul is focused on this kind of very dynamic way of doing it. So there's a couple of different parts of this, and we'll get into this. But the idea is that you would use things like service discovery to find the objects in your network that you want to talk to. You have segmentation, so you keep them apart. And then you can also do things like storing key value pairs so that you can do discovery and dynamic configuration if you need to do so. So everybody kind of has the same view of the reality of what's going on in the network. So the summary here, and I apologize, we're going like super fast because we're trying to be very focused, is that Consul basically has 3 kind of core use cases. We refer to them as service discovery. And what we mean by that is like I can declare myself as a service, as an object, and saying, hey, I have this service, I'm service A, and here's where I'm listening. That's expressed as, can be expressed as DNS. Also segmentation, right, where we have these 2 objects that want to talk to each other, probably 2 containers, or it could be a VM in a container, or really anything actually. And then they can form a secure connection to talk to each other. And Consul manages that for you. And then the kind of key value store functionality, which is kind of core to what Consul is. But the idea is that you need to be able to push dynamic configuration information someplace and have that stored in a pool. You need to have multiple members sharing the same information. You need to have it distributed. You need to have it eventually consistent, and Consul brings all that capability to you. So that's kind of the 10,000-foot view of what's going on with Consul. However, what we really want to focus on now is how you consume Consul in the cloud. We have a lot of customers that are running Consul right now in AWS or Google or Azure or their choice of clouds. But one of the things that people have told us consistently is that what they would really prefer is that Consul is available as a service. And at HashiCorp last year, we announced our intention to do that. So what is Consul as a service? So Consul as a service is exactly what it says on the tin. It's a way for us to deliver Consul in a managed format that you can consume without having to worry about the tedious details of actually deploying it, managing it, patching it, sizing it, responding to trouble tickets if a host goes down, all those kinds of things you don't have to worry about because we take care of it for you. It's a completely managed service. It's owned, operated, managed by us, by HashiCorp employees. And we're delivering it at the moment on Azure. So the idea here is that you can relatively quickly and easily deploy clusters in Azure and then consume them across your distributed applications, whether they're running in AKS or running in a VM or pretty much any form factor you want. As I mentioned, it's fully supported. I think the biggest piece of this is probably patching. Most of our customers, when we ask them what are the top favorite features of Consul, they don't say that patching is their favorite feature. Nobody likes that. That's not the fun work that you get to do. So we can take that work away from you and make sure that we keep the servers up to date, that everything's patched, everything's secure. Especially if you have something urgent, like an emergency patch due to a 0-day vulnerability or something like that. It's not something you want to stop your regular work to fix, right? You want us to take care of that for you, and that's what we're doing here. Because it's the core Consul functionality, the use cases we talked about before, like service discovery and full service mesh, will work in Consul as a service. I think it's really important to note that just like all of our other products, HCS is very focused on making sure that we carry forward all the goodness that comes from the open source products. Obviously, the open source version of Consul is very critical to everything that we do here, and the community around that is super critical, so we don't want to walk away from that product. So the core bits are there. It is Consul. If you know Consul from open source, you'll be very familiar with Consul as a service. So what does that really mean? Well, it means that when you go into Azure Portal, you can go and configure Consul resources. You can deploy a cluster. And in fact, I'm going to show you a demo of me doing that in just a minute. The core access to this cluster is managed through Azure Active Directory, as you would expect. And then the billing comes through your Azure bill. So if you are an Azure customer and you like being an Azure customer and you want to consume that way, then you'll be able to do that. And this is definitely designed for customers that have chosen to use Azure for some portion of their compute needs. So what does this look like? So there's a little bit of complexity in that this is what's called a managed application in the Azure universe. And so what that means is that there are actually two resource groups involved in the deployment. One is the resource group that you own, the customer resource group in this picture here. But what we do is we introduce a new resource group that is the managed resource group. This is managed by us, by HashiCorp, and this is where the actual Consul objects are deployed. And we deploy our own VNet. And then the idea is that when you want to connect other services to this resource group, then you would use VNet peering in Azure to do that. Mechanically, under the covers, the way it actually works is that the marketplace, the Microsoft's Azure marketplace, calls us through a well-known API. Our backend services then provision and manage those resources. So there is a shared responsibility model here. We do have full access to the underlying Consul hosts because we're responsible for them. We patch them, we maintain them. So we have protocols in place to make sure that those objects remain secure and there's not unauthorized access to them. Human beings at HashiCorp are not saying they're allowing you to do these hosts. That's not what's happening. They're being managed programmatically in a secure way. And so the idea here is that you have a long-running managed infrastructure that is supporting your custom applications that are sitting in the resource group that you own. So let's make this a little bit more practical. So the process of actually deploying HCS takes a little bit of time, which is more than we have at the moment. So I cheated a little bit and I recorded it. So this is kind of like my cooking show here. So when you go into Azure Marketplace, you actually see the offer here. Oops, clicking in the wrong place. And when you create it, as we mentioned before, you have these two resource groups. You have the resource group that you manage, which lives in a given region. And then what you do is you just give the application a name. This is the name of the actual managed application in the Azure side. And then you have to give Consul a cluster name. So this is exactly what you would think it is. It's just the standard Consul functionality when you deploy it. I'm going to leave all the other fields blank here. And then you go through a really quick validation section. You have to accept the ULUB, all the normal stuff, and then you click Create. This is the part of the demo we're going to compress a little bit here because this takes about 15, 20 minutes. And my entire presentation is 12 minutes, so we didn't have time to do the whole thing. So we're going to go ahead and compress it. And when it's deploying, you see this kind of status message here. And it just kind of gives you the kind of holding pattern, tells you what's going on. So I'm going to exit out of here. So that was kind of the prepared cake part of the cooking demonstration. So now we have our lovely risen souffle here. And this is a running live environment, so we're no longer in the video. And what you can see here is in my Azure console, I have a managed application. This managed application is a console cluster. If you are an Azure user, hopefully this is fairly familiar to you. It looks a lot like an Azure object. There's one little trick here, which is that we've introduced this new section here in this tab. And when you click on this, what you're actually getting is just full-on console, exactly what you would expect. Now, if you ever used console before, hopefully this UI is very familiar to you. Obviously, you can interact with this also from an API or CLI, just like you normally would. So at this point, what you have is a full normal running console cluster, and all the normal console cluster things would apply. So we're going to shift gears here a little bit, and I'm going to hand off to my partner in crime here, and we'll talk a little bit about what you can actually do with this thing once you have it running.
Okay, so let me stop sharing video so I have as much screen space as I possibly can. So thank you, Alex. Good morning, everyone. It's very early here. I'll be taking the setup that Alex has just shown with the console cluster, and I'm going to show you how you can use that to actually migrate from a monolithic application running on a VM and move that to microservices running on Kubernetes. So in the case of what Alex just presented, that would be AKS, right? And I have about 10 minutes to do it, where normally companies take months or years. So let's get started and go through this quickly. To speed things up and make it possible for you all to download this demo afterwards and play around with it yourself, I've created a local version of the environment using a tool we have called Shipyard. So we'll be simulating a few things, but the interfaces remain the same. So the lessons learned will still apply here. So we're starting off with this situation where we have our virtual machines running our monolithic application. We have a payment service, which is the big monolithic application, which is fronted by a proxy we call web. And there's the AKS cluster and there's HCS, but they're unused for now. And the proxy is actually statically configured to route traffic to the IP of the payment service. So this is a quite fragile setup. What we actually want to move to is to a microservice architecture where the applications are running on Kubernetes and they're split off. In this case, we've split off one microservice, the currency service from the payment service. And all these pieces are communicating with each other through the service mesh. So this makes everything way more robust, dynamic, and secure because the applications can find each other through service discovery. And then all communication through these sidecar proxies is actually encrypted with MTLS. So as I said, we're simulating some of the components in here, and that's to make it easy to run locally and quickly. And one of those things are actually the VMs themselves. So instead of having VMs and waiting for them to spin up, we're actually using containers with multiple processes in there. And in this case, we'll have our application binary, a console agent configured as a client, which is connected then to HCS, and we have our sidecar Envoy proxy, and this is all managed with Supervisor. So let's start making the first step from that statically configured environment, and we're going to migrate towards these microservices. So first, an easy step that we can do is take that proxy and already move that to Kubernetes, right? It's an Nginx or an HA proxy, and there's already containers for that, so it can easily be migrated. But then the important step, what we need to do is we need to register these services in the Consul service registry, and then launch sidecar proxies for these that then get configured through Consul to make that communication between these services possible. All right, so let me hop on over to code and show you how we do this. So here we have the service registry for the payment service, and all. Hello, I think my Zoom just crashed, so let me quickly reshare.
Yeah, Eric, we can hear you again now, but you did break off for a moment there.
Yeah. Oh, where did it cut off?
About 30 seconds ago.
Okay, so that's about when I went to code, right?
Yeah.
Okay, the wonders of the internet during this time. Okay, cool. So here we see the first service that we're going to register, and we have to give it a name. So in this case, we give it the name of payments, and we specify the port that it's listening on, so other applications will actually know how to contact it. I'm giving it some metadata, which will be important later on. So I'm giving it a metadata version, and this is the first version of this service. And then very importantly, we're actually specifying that we want a sidecar service for this actual service. So it'll actually spin up an Envoy proxy for us. And then here we've containerized the proxy. I'm just using something called fake service to actually show the call chain in here. And because we're running on Kubernetes and we've installed the Helm chart for Consul, we actually can make use of some very useful features. So we're actually going to inject the sidecar proxies automatically if we have this annotation set up. And then since web needs to contact payments, we actually tell it that there is an upstream. So we want to be able to reach payments, and we want to do so on localhost 9091, which, as you can see, I'm actually calling here. And then very importantly, because we actually want to use the L7 features of Consul Service Mesh, we set the protocol to be HTTP, right? So we actually have this already up and running. Back here, move Zoom to the side because it's always in the way. And we can see that we have Consul running, but we also have our two services, payments and web, and their sidecar proxies. And if we actually test this, we can actually see that web can contact payments, right? And web has an IP in the Kubernetes space, and then payments still has that static defined IP. Okay, cool. So now that these applications are meshed together, we can actually start with the more important migrating part of the move. And we're going to split off pieces of functionality, and we're going to do so step by step. So we're going to start off with a simple encapsulated feature, the currency feature, which is right now a in-process call from the payment service to the currency. And we're going to split that off into its own little microservices. So currency v2, which we can then call separately, right? So let me show the YAML for that, and we can actually start applying these. So here we have the currency service. It's a very simple microservice. It just responds with the amount of money that it is in a certain country. So if we input $10, what do we get back? Well, this might be Australian dollars. And again, we're injecting our sidecar proxy and setting the protocol to HTTP. So let's actually apply this. So I'm applying this entire directory right here, and it's actually sending in Kubernetes YAML, as we can see. So if we go to console, we now see that we have the currency service and the sidecar proxies up and running. Okay, but we don't have any way to call it, right? If we call /currency, we still end up at the payment service. So we want to expose the currency service, but we don't want to interrupt any of the traffic for our normal users. So what we need to do is apply a service router. And I'm going to apply a service router for the payment service so that when we call /currency, that normally gets routed to the payment service, we actually redirect to the currency service instead. So let's do console config right. So this was v3/that. And we've now applied this central configuration. So that means that if we now would try this call again to /currency, we actually end up at currency. And if we go to anything else, we actually end up at payments. Great. So now we can actually test this feature separately and make sure that everything is robust. All right. Oh, switch back to the slides. So now that we have this microservice for currency, we need to actually start using it. So we're going to deploy a new version of the payment service that actually calls this microservice instead of doing an IPC. And we want to route traffic to this new version, but only if we are a developer of the application. So to do this, we will actually split the service of payments into two subsets. So we're going to have the old version, that's where the metadata comes in, version 1, and we're going to have version 2 of this. And then version 2 will have an upstream of currency. So let's switch back to code and actually do this step. So here we have our new payment service. I've already put it in Kubernetes, but that's just for ease of use in this demo. We're again going to inject the sidecar service. And we have an upstream of currency that we want to reach on localhost 1991. And again, the protocol is HTTP. And here we're calling that upstream service, right? So let's apply this configuration. So that should now be spinning up. We should now have a extra payment service in here. Here we have the old one, and this one's actually on AKS. So that's all going well. But now we need to be able to call this. So we want to configure it the same way that we did with the currency. So in order to do that, we actually first need to create these two subsets. So we need to specify that we want two subsets, one for v1 if the meta version is 1, and v2 will be if the meta version is 2. And then very importantly, we define that the default subset is a v1, so all our current users are actually still being sent to v1. So let's apply this configuration. Okay, very cool. Now, if we actually test this and we go to a route, we get the old payment service, but we also want to be able to reach our new one. So in order to do that, we'll create another service router, again for the payment service, but this time we'll try to match on HTTP headers. And if the header says that we are in the group of developers, we want to actually route to a subset of payments. So we're actually going to route to v2. So if we actually apply this, we can now give this a go. So curl 9090, and as we can see, we are ending up at the payment service. Okay, that's all good. And what if we pass in our headers? We actually get routed to V2 and the currency microservice. So this means that we can actually test this service without disrupting any of our users while this is going on. So heading back to this. So now that we've been testing this and we know that the service functions properly, we can actually start to expose it to our end users. And we want to do that slowly. So we're going to create a canary release and give it to a small portion of our users and see if everything goes well, and then ramp that up from there. We'll then ramp it up to 50%, see if everything still goes well. And then if there are no errors, we'll keep an eye on our monitoring tools. We can actually switch over 100% to the new version. We can keep the old version around, so in case we do get any errors or find any bugs, we can always roll back just by changing these values in the traffic splitter. And eventually we can decommission the old version and start breaking off the next piece of the monolith. So let's actually switch to that, right? So here we have the initial service splitter, where we use these same subsets that we've defined before, V1 and V2, and we're going to set the weight 100% on the current version, right? So we'll actually write this configuration, V5, and let's do 100% to the current version. So if we curl localhost 9090, we actually see we still get the old version. Good, 100% is going there. Okay, so now that we have this in place, not author Nick, he didn't do anything. We're going to ramp it up to 50%. And we started exposing this to 50% of our users. And with sticky sessions, they would only get that current version. So we can see that we get a healthy split between the old and new version. Everything is still going great because we don't create bugs. It's the users that do those. And we're now switching to 100% our new version. And all our users have now migrated to this new version. Now, the cool thing is that we've been doing this by only changing configuration mostly, right? We've had to split off that microservice, but we haven't interrupted any of the service for our users. And by doing it this way, we can actually slowly move towards a microservice architecture instead of having to do a big bang transition, right? If you would like to try this out for yourself, check out this repository. It contains everything you need to run the demo, and it has written instructions on each of the steps. It actually opens up documentation when you run it, and it takes you through all the steps as all the screenshot and all the commands you need to run through. And it's entirely self-contained, so please give it a go. With that, thank you, and I'll hand it over to the next speaker.